Alright, so today we're going to continue on from Friday, which we're going to talk about congruent figures. Remember, the biggest thing is a congruent figure is a figure that's the exact same size and shape as its image. So mainly the copy of it. We didn't change it, we didn't stretch it out, we didn't make it smaller, we didn't distort it at all. So if you would turn into your foldables, it's the one that says similar congruent figures. You turn to that page. I know that there's a dilation one in there. That's going to be tomorrow, just because there's more to dilations than what we need in our foldable. So if you open up your foldable to similar congruent figures, the pink sheet that's on the top, we're going to put those notes down. So the first part of the note says, a rigid motion is a transformation that preserves the length and angle measurements. Translations, reflections, rotations are rigid motions. Let's make sure we get this all copied in our foldable. Wait, foldable, open, copy it down. Wait. What page is it? It's off similar and congruent figures. Parker, do you have this, Turpin? Is it copied in? Alright. Okay. So, second part we have. Second part we're still putting in says, two figures are congruent figures when one can be obtained from the other by a sequence of rigid motions. Congruent figures have the same size and shape. Angles with the same measurement are called congruent angles, and ones with the same measurement are congruent sides. You're right. Yeah, you're on the right page, bud. Okay, so the biggest thing that we're trying to learn here, the explanation, and I gave this, you can copy this. Biggest thing is a rigid motion. The last few days, what we focused on in class was we worked with translations, we worked with rotations, and we worked with reflections. Those three transformations that we have done, those are all our rigid motions. So now we're going to take those rigid motions, and that's how we determine if something is congruent. They are congruent when they are the same size. So if I look at this example, yes. Okay, so the triangles are congruent, and when I look at this, when we say they're congruent, it means all of our angle measurements are the same and the side lengths are the same. Okay, an important thing is when we're identifying, Zachary, when we're identifying your triangles and your angles and your sides, we do that through the vertices, through their points. So down here, when I said the sides are the same, an important thing we want to do is go the same direction. So when I said side AB, I started at A and I went up to B, and I put this little equal sign with the S on it. That means congruent. So they're telling me side AB, which is red, right here, is congruent with DE. So here's a tough question. What if I told you the measurement of AB is 5 inches? What would DE have to be?
5 inches.
Yeah. That simple. If AB was 5 and I said that DE was congruent to it, DE also has to be 5 inches. They said BC, they put that in blue. So BC is this angle.
Who said that?
Is congruent to these two. Now, if I say it is 11 inches on this one, what would EF have to be? Have to be 11 inches. Now, the biggest thing that we have to make sure we don't mess up right here in this common error says, when writing a congruent statement, make sure to list the vertices of the figures in the correct order. So, when we say it's important that you match up corner to corner, we can't just randomly choose, because if I do that and I mix up the corners, that's going to change our shape. So we have to make sure we match them up. This should be fairly simple. I'm going to go ahead and I want everyone to turn to, in their notebook, open up this. If you would turn to 2.4, in your notebook, 2.4, please.
I'll be the dead one. What's your money for?
Turn to 2.4 in your notebook so we can do this together.
No more hits.
Set 'em up.
This notebook has my notebook.
I'll give this to you for now.
Here's my thing.
You've had this all set up. Stay focused. I don't have to be marking and sitting out. I want to keep everyone in here so we can all get this. This is not too difficult. Okay, what you're going to look at, it says, I'm going to go to my OneNote. It's matching exactly up with yours. Don't worry. I know you're on 2.4. But we're going to look at this. I'm sorry, I went one page. Oh, shoot. I messed up. Keep the tracing paper, though. But you have to go back in your folder. I got ahead of myself. I thought this was on another page. This is actually on your foldable. I'm sorry, that's my fault. Still in your foldable. We're right here. Okay. We are right here. Here's the question that I'm asking you. You should be in your foldable. Troy, please follow along with me. You can lose your trace paper, then you can't be using it. Okay. Be on your foldable, please. On that pink sheet, it says, identify congruent figures. Identify any congruent figures in the coordinate plane. Okay. I'm going to give a short little participation thing for Starbucks. I know it's not much, but a couple Starbucks on this. Can anyone find two triangles in here that are congruent?
Ooh, I got you.
You have to be able to prove it to me, though.
Oh.
I forgot what you mean.
Congruent means same size and shape.
Oh, I found it.
All right, Turbin?
Yeah. So take the one in the first quadrant and then reflect it on the.
But okay, how do I identify a triangle?
I don't know.
Okay,
Yeah.
we identify a triangle.
Looks like
Hold on. Zach. We identify a triangle by saying triangle, and then what points? What are the three?
B,
Zachary.
A, B, and C.
Sure, space. What?
Yeah, A, B, and C.
Okay, so if you set A to B to C, alright. So triangle ABC. Okay, it is going to be congruent to which triangle?
What? The
JLK.
Okay, yeah, that one.
Okay, and this follow us. You guys did good identifying the triangle, but we want to name it correctly. Because remember, we want to match the points up. So if this was point A, that would match up with J. B matched up with K.
Find another one. JK.
Hold on. Now, Parker, do you know how? Sure, I'm sorry. Because you said these two were congruent. How did I get from ABC to JKL?
Reflect on the axis.
Perfect. Reflect on x-axis. Alright, is there another triangle? Sure. Okay, select me. Easton?
PMN and FDE.
Let me switch colors. P, M, and N. And what? Perfect. Triangle P, M, and N is with triangle F, D, and E. Okay, Parker, I know you weren't here for some of this, but how did I get from PMN? How did I get to FDN or FDE? How did it get from here to here? Okay, slide. And instead of sliding, we call that translate.
Oh, I just said that.
Okay, now where did I slide?
Into the DMs.
So, which direction was I sliding?
Down.
Okay, we're gonna go down. So translate down. How many units down? So if I start here at N, how far do I have to go down? Good. So translate down 5 units, comma. Now if I slid down 5 units, I'd only be right here. So then I'm gonna have to go.
Oh yeah, over what?
Yeah, and don't say, you can't just say, oh, you have to tell me which direction.
Left.
1 unit. Yeah, I'll get you some Starbucks as well.
Oh,
Alright, so, looking at the next part, it says, you're supposed to try this. So it says, triangle has vertices at, I'm going to go ahead and mark these in here with purple, 0, 4, that's X, Y is at 4, 4, Z is at 4, 2, and I want to know, does this triangle have any other triangle that it's congruent to?
Oh, that one, yeah. It's the other one.
Ryan?
Would it be Q, P, and R?
So triangle X, Y, Z is congruent to triangle which one?
Q, P, and R.
Yeah, and I'm going to name it though the same way. Since I started with X, I'm going to go R, Q, P. Really work on identifying those points together. Okay. Now, how did I get there? Ryan?
that was good.
You would rotate it clockwise.
No.
What?
He said
What
no.
about the origin?
We should put that in there, but still have a mistake.
I said
One direction. Oh, wait.
this way. See?
Thanks,
This
Sierra.
purple triangle would have ended up in quadrant 4.
See?
So you gotta turn it.
So you go
clockwise.
I told you, just say it.
But it's not
So
the
you go
same.
It was
clockwise.
the order.
Oh,
It go off the grid.
Ryan.
Yeah. Okay.
What? Lily?
You got
Okay. Now let's have you guys do this. This is also gonna be worth some points. So let's turn now to that little 2.4. Alright, 2.4 should look like this one. Wait, easily. Follow along. Okay, we should be on this page then. Yes. Everyone should be on 2.4. Oh. I've already given you out the tracing paper. So using tracing paper should make this easy. The whole purpose of tracing paper is so we can visually see our math happening, where we can see the changes and we don't have to try and picture it in our head. So if I look at this one, the very first one says, describe the sequence of rigid motion. This is kind of like what we worked on Friday. So what I want, I'm going to go to my notebook. It will look the same as yours, so you can see the colors. The red, here, let's put that away. Right there by your laptop. So, the red figure is congruent to the blue figure. We need to figure out how did I transform this. That's what today's lesson is all about. Can you describe with rigid motions, either through translations, rotations, reflections, or accommodations? Physically, go ahead. You should take your translation paper right here. And when we use in our tracing paper, I'm going to go in the corner. Make sure you copy down the axis first. Then I did the figure. How can I physically move this to get to the other shape? How can I physically change this? So physically, show me, how are you changing this? How do I get from the red shape, which was the bottom left, to the top right? Here, hold this for now. Sorry, if it was yours, you shouldn't have had it. Okay. Zachary, come on. You should be on 2.4. If you don't want to, I can find somewhere else for you.
Bell. See? I can get it.
Transparency paper, how do we turn these?
Your book was that clear or white?
So you gain marker for class.
No, I had a pin, but it didn't work.
You have to go sharpen it. I'll leave back. Alright, wait. Anyone figured it out?
I know how.
Alright.
I think.
What do we got?
Okay, so what I did is I traced the shape.
Everyone should be listening. Okay. Zach, I need you listening right now. Braden's going to explain this.
So what I basically did was I traced each shape and then I rotated them.
Okay, so we're going to rotate. Which direction am I rotating? Clockwise or counterclockwise? Right or left? So if I go left, that's this way.
Oh.
Is that what you want to do? Huh?
You go clockwise.
Okay, so he's going to have me go clockwise. How many turns? Okay, so if I turn once, I line everything up still. I still have my X and Y coordinates lined up. So I rotated 90 degrees clockwise. And now what? They're not matched up yet. So now how do I get there? Ben? Okay, which direction am I going to translate?
One up and
Alright, so if we go one up, we translated one up, and then one, two, three, four, right.
That's tricky.
Okay. Honestly, today, everyone should be able to do this because you're going to do two main things. One, you first have to decide, are the two images congruent? Are they the same size and shape? If they are, you're going to use your tracing paper and you have to decide, how do I rotate, reflect, or translate it so they get on top of each other? This, we rotated 90 degrees, so you would be writing that in your answer. I would say, rotate 90 degrees clockwise. And I would say, translate 1 unit up, 3 units. Wait, was it 3 or 4? 4. 4 units right. That is your answer. That is what I'm expecting you guys to have down. This is all your answer is going to be. So, let's have you try. This is also still on your green sheet. It's number 4. On number 4, here's our two shapes. The pink is the bottom right one. The blue is on the top left. How can I translate, rotate, or reflect to make the two congruent? And then one big hint, when you translate, you cannot go on an angle. We either go straight up and down or straight left and right. So, who can describe this one to us? You can just move your paper. I'm using the other part of it.
slid upward.
That's what she said.
I gotta get my Starbucks out. Who did I do? There was someone else.
It was clearly me.
Yeah, I know you want to be me.
Your Parker 1.0.
What? That's racist.
Okay.
What's your
Doesn't work. Yeah, let's see who really was it. It was Parker. It was
I'm too.
Okay, for a couple Starbucks, can we explain this? How am I going to translate, rotate or reflect to the second image. Sabina?
Okay. So after you trace it, right?
Okay.
You go to the left.
Okay, so remember, don't say go left. We're going to translate left.
I'm gonna translate the direction opposite.
How many am I going to translate left? Okay, so 1,
Wait, no, wait.
2,
3.
3. Alright? So first thing I translate 3 left. Now what?
And then you go. Hold on. 1, 2, 3, 4, 5, 6.
So 1, 2, 3, 4, 5. Hold on real quick. So our answer on number 4, you would first translate 3 units left, boys. And second, we translated 5 units up. What's your question, bud?
Couldn't you just go counterclockwise?
What do you mean? Turning it?
Yeah, twice.
Okay, let's look at it. Braden asked, could I have rotated this counterclockwise 2 turns? So counterclockwise 180 degrees. If I did that, there's 1.
Boom. That's what I did. Turn it twice.
Does it match up?
I mean, my hand.
But did you mark? But when I looked at yours on your hold on, on your tracing paper, you don't have your X and Y axis marked. If you do that, now you go to 20. Okay, listen up to this, because this is actually pretty good. I like that. Braden, I'm probably going to give him some Starbucks for it too. He looked at this, and Braden asked, could I have rotated this twice? So if we're watching and I rotate it twice, you have to keep your axes matched up. 1, 2. Well, they're not on top of each other yet. So I could say rotate clockwise 180 degrees, then translate left 1 unit. That would have worked. Okay, you guys need to figure out number 5. Okay, number 5. Figure out how we can translate these 2 triangles. The pink one on the top right to the blue one on the left. Alright. What did I do on this one? Alright, so focusing on this. That. We can wait, we'll have extra work, we won't have time to get it done.
Are you eating my apple right now? Apple, I think, is back in my day. Mr. Sissel, are you eating my apple right now?
I'm waiting for us to be ready.
Shut up!
Nice.
That's not a nice word. Ooh.
Okay,
Got
cut
it.
it. Shut up.
You guys stop playing around. Please sit down.
Okay. Hood down.
Are y'all still talking?
You go, okay, Sam.
You know he wasn't
Right.
Ainsley.
Right.
Oh!
Okay. Okay. How can we describe this one? How do I go from the pink triangle to the blue one? The pink one was the top right because I had it on OneNote. I'm just going to tell you. Oh, see, we started losing our focus again.
Oh my God, be quiet.
Benjamin, what am I going to do first?
So you want to rotate 90 degrees counterclockwise.
Okay, so counterclockwise, I'm going to turn and I keep my X and Y axis lined up.
And then translate it
3 units down, so I'll go in 1. When I do that, I always look at my X axis and I just go to the next line. So that's 1, 2, 3.
And then you translate it 1 unit left.
Perfect. Alright, so we did this one. We would have said rotate 90 degrees counter clockwise. Translate. What'd you say? 3 down?
Be quiet.
3 down, 1 left.
You. Stop talking.
Whoa, hey.
Alright. Let's go to the next one. I'm not worried about this. So here's what I'm going to do. This last one, same thing. How do I get from the original emoji to the second one? No. If I rotate it, pay close attention because if I took this image and I rotated it counterclockwise like you said, the tongue would be up here.
Oh, you gotta turn it.
Well, if I turn it hold on. If I turn it clockwise though, then it's gonna be the mouse gonna be on the left side.
That's what I'm saying.
Yeah, you just turn the smile around.
Okay, so you would do your first step. You would turn it counterclockwise 90 degrees, but then we have to reflect it.
Once you translate it twice over left side.
No, with this we're not gonna translate sliding anywhere.
Okay. Okay.
Go put it in the trash can, please, Barbara.
Put it in the trash.
Alright. T on this, we weren't translating, we're not moving. We're just saying, we're gonna do this one to make it look like that one. So we only looked at rotation and reflection. Okay, if we turn it counterclockwise like we said, The image would have been where like the eyes were here, smiles here, but the tongue was out up here. So then we what?
No, 3 times.
Wait, it is.
Wait, how's the tongue on that?
Oh,
one
no,
on
no,
that
no,
side and on the other side is on
The
that
tongue is totally blacked out,
Look.
dog.
Yeah.
It wouldn't. Watch this. It wouldn't matter
Yeah,
because
Just for a second.
alright, if I took this one and it was like that, if I went ahead and I rotated it, and I'm going to rotate it, you said counterclockwise, so I'm going to go left 90 degrees. So let me take it right here so you can see it. Okay, if I rotate it 90 degrees left, it'd look like that.
Okay, so how's the tongue on the other side? You have to reflect it.
So if we hit reflect on it, I don't think it'll let me reflect it. But we would have to reflect it. We're going to take it, it's like a pancake, I'm going to scoop it up and just flip it over. If I did that, this would go on the opposite side. Okay, so here's what I want you to do. Your homework. You will be able to finish this in class right now if you start working on it. Alright. Let me finish homework and then I'll be done.
Let's do this.
Okay, today's Congruent Figures Day 2. On ABC, there's 2 houses. They're telling me that they are the same. So, knowing that they are congruent, you have to find out what the length or the angle measurement is. The bottom one, there's a picture of 2 constellations. You're doing the same thing. Telling me, are they congruent? Yes or no. And then you have to tell me, Zach. Yeah, he's in safety for a reason, not for you to come and play with him.
Save that for after
Have a seat. Then you have to tell me, how did you get the 2 to be congruent? So on the last one, how did I get from one shape to the next? Hit the fuck button.